Hey guys, this video will be talking about a more complicated example of linear velocity graphs, linear velocity time graphs. So let's take an example here and we will see what information we can deduce about it. We know that we can talk about all the three of the quantities, the displacement, the velocity and the acceleration from by calculating an observation skills and our observation skills about the velocity time graph. Let's see. Okay, let's take this graph here. Okay, so this line moves here, then it moves here, then it moves here, 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 and let's say here. Okay, so this is our graph. Let's just give some random numbers here. This is, for example, 6. This point, let's say 10. This point is, let's say, 12. This point again, let's say this is 7, and this point is here. Let's give some data on the time scale. This is again a velocity time graph. Sorry to tell you about this later, but this is a velocity time graph. This is the velocity, meters per second, and seconds for time. This is, let's say this is 2, and this is, let's say this is, it doesn't look like 3, but it's 3. Okay, this, let's say this point here is a 6. This point here is an 8. This point here is a 10. Okay, or probably a 12. Okay, now first of all, let's talk about the velocity from this example. So this is 0. So initially, when time t is equal to 0 seconds, the velocity is 0. At time t is equal to 2 seconds, the velocity increases till it goes to 6 meters per second. Now you should already identify that this is since this line is not horizontal, there has to be a gradient and it will be accelerating. We will just find the numerical value, but you should have the sense that at this point it's accelerating. Since line is not horizontal, there will be a gradient, and we know the gradient of a velocity time curve. If it exists, it means that it is acceleration. So we know that it accelerated uniformly. It's a uniform acceleration throughout. There will be, this is one straight line, so this is a uniform acceleration, and the velocity increases from 0 to 6 meters per second. Okay, now let's say from time 2 to 3 seconds, the velocity goes to 10 meters per second, like this. So we again know this is acceleration, since the slope is not horizontal, otherwise the acceleration would be 0. We know this. So it's again accelerating, and we can say that the acceleration has increased from before because the slope is steeper this time. This one is steeper. B is steeper than A. So acceleration is more here. We will find out the numerical values, but we can predict that the acceleration will be greater. The numerical value of acceleration of this line would be greater than this one, and this is uniform acceleration since the line is straight here. So we'll see all that with the gradient, but I'm just predicting. Let's just say, okay, then at t is equals to 6 seconds, the velocity reaches its highest point, which is 12 meters per second. Again, there is an acceleration since there is a gradient of this line. This is a slopey line. If I sit here, I'll just slide down. This is a slopey line. So there is a gradient which will be positive because the line is going from bottom to top, and it is a uniform gradient. So I can't say much about this gradient, but I can say that this line, this gradient, will be lesser than this gradient, since obviously I'll slide more here compared to this. So this is steeper than this one. So the gradient of B will be more than the gradient of C again. Let's talk about this point, t. At time t is equals to 8 seconds. Let's see what happens at time t is equals to 8 seconds. The velocity changes from 12 to 6 meters per second, which means it's slowing down. So velocity becomes 6 meters per second, which means it's slowing down or uniformly decelerating. We can see that there is a gradient, so there should be a magnitude of acceleration, but since this is coming from top to bottom, this will be a negative gradient, which means it is decelerating. All these predictions should be made before you actually come to the calculations. The calculations will give you the numerical answer, but even without this, even if there are no digits here, you can just predict this. I don't need numbers here to predict this. I can just go on predicting about this because of the sense that I have about gradient and acceleration. So this is a negative gradient, so it is decelerating. From here to here, the velocity from point 8, velocity here is 7 meters per second. I'm sorry. From 8 to 12, the velocity stays as 7 meters per second. This means the gradient is horizontal. There is no change in velocity, so definitely there is no acceleration. So that is gone. This is zero acceleration or constant velocity. Since we know this is not at rest, it's at constant velocity. Whenever an object moves at constant velocity, it has a zero acceleration. Always remember that. So from here to here, again the velocity is decreasing. The velocity is decreasing and the car is decelerating. So at time t is equals to, let's say this is time t is equals to 14. So at times t equals 14, the velocity is back to 0. So it comes back to 0 from 7. So again it has decelerated. Now you should all make all of these things, all of these predictions. By now you should be able to make all of these predictions by looking at the graph. Now we will go, let me just clear this. This is not required. We can see this from the graph. This is not the important bit here. My stupid eraser. Okay. Now, let's talk about the information I can gather about acceleration in this part. Acceleration is given by gradient. I predicted that this would be a positive gradient here because the line is increasing. So let's see the gradient. The 2 points are 0 and 6 and 2 and 7. Whenever I use this eraser, my pen starts to stop working. Or, okay, that is ironic, starts to stop working. Yes, good. So, sorry, this is 2 and 6 here. This point is 0 and 0. This one. And this one is 2 and 6. So let's see the gradient here. This would be 6 minus 0 divided by 2 minus 0. y2 minus y1 would give me 6 over 2, which is 3 meters per second square. So this is positive acceleration, and with every second it's increasing its speed by 3 meters per second. So we can see that in 2 seconds it has increased its speed by 6 meters per second. So that is correct. Now let's see the acceleration at point B. The first point is 2, 6, and the second point is for this 3 and 10. I'm predicting that this would be a positive uniform gradient since it's increasing, and that the gradient from B to A would be from the gradient of B would be greater than the gradient of A because the line is steeper here. Let's see. y2 minus y1 over x2 minus x1. This would be 4 over 1, which means 4 meters per second square. So yes, my predictions are right. It's a positive gradient and it's greater than the gradient at A. It's 4 meters. So during this interval, the speed increases 4 meters per second every second. Okay, so this is what is happening. So you can see from in 1 second it just jumped to 10 from 6. There's a difference of 4 meters per second every second. Now part C. Let's talk about part C. Again, the gradient would give us the acceleration. We can find the acceleration. It's easy. Let me just quickly take the points 3 and 10. This point on this line and this point on this line. 6 and 12. So 12 minus 10, I predicted a positive gradient and that this would be less than p. 12 minus 10, 6 minus 3. This would give me 2 over 3, which is obviously 0.67. So meters per second square. So here it's increasing at an acceleration of 0.67 meters per second square. Although it is accelerating, but still the acceleration is less than p, as we predicted because of the steepness of the gradient. Here I predicted at point D, I predicted that the acceleration would be negative. So let's see, let's just take 2 points here, 6 and 12 and 8 and 6. I think you know the gradient now, so let me just quickly do it. 6 minus 12, y2 minus y1 over 8 minus 6. This would give me minus 6 over 2, minus 3 meters per second square. This tells me that it has a magnitude of 3 meters per second square, but it's decelerating, it's slowing down at that rate, slowing down by 3 meters per second every second. So it's decreasing its speed by 3 meters per second every second. So in 2 seconds, okay, sorry, I just took this 8, 7. This is 8, 7. So this would be minus 5 over 2 here. This would be minus 2.5 meters per second square. So every second, slowing down by 2.5 meters per second. For this line, we know that the gradient is 0, so there is no acceleration here. For this point, final point here, we can find the acceleration at E here. Let's see the 2 points. This is 14, 0. 1 point is 12 and 6. The other point is 14 and 0. Find out the gradient yourself. You can do it. And we can predict that it's a negative gradient. So it would be decelerating and finally coming to a stop at this point. So this is all cool. And we can find this out and you will see that it will be a negative gradient. And this is the second information we got after the velocity. This is the acceleration, numerical acceleration. What if the question also asks you about the distance moved? Okay. You can see it's really powdery here. But it's hanging a little. I don't have a very good computer. It's an old version of Mac, so it hangs a lot. Anyway, so what if it asks about the distance moved? Now, for the distance, we know we find the area under the curve. So if it asks me calculate the area moved in 3 seconds, the distance moved in 3 seconds by the car, what I can do, I can break it down into two shapes, two regular shapes, so that I can find it easily. Let me just break it down into two regular shapes. This one regular shape, shape A, and the other one, shape B. This one is a trapezium, and this one is a triangle. So for shape A, formula is half times times height. Formula for area of a triangle. So let's find out the area of a triangle. Half times 2 times 6. This becomes 6 meters. So in the first 2 seconds it moved 6 meters. Now let's see how much it can move in 3 seconds. This is the 3-second mark here. How much it can move in 3 seconds. So from 2 to 3, let's find out the distance. Here also, the distance. So from 2 to 3, let's find out the distance. It's a trapezium, something like this. For a trapezium, the formula is half sum times sum of parallel sides times height. Let's see, we have two parallel sides, this one and this one. It doesn't look parallel, but it is parallel. We are assuming it is parallel because of the limited resources. So this is 6, one is 6, one parallel side, the other is 10. So it will just be half times 6 plus 10 times the height. In this case, this will be the height. So this is times 1. So this will be 6 plus 10, 60, times 1 is 60 again, divided by 2 is 30 meters. But during this interval, the car moved a distance of 30 meters. And in this interval, the car moved a distance of 6 meters. So the total distance it moved in 3 seconds is 30 plus 6 meters. This is 36 meters. This is our final answer. So we have seen a complicated problem. This was a very painstaking problem here, but we have seen how to analyze this problem completely. We can, for a velocity time graph, we can talk about the distance, the displacement, the velocity, and the acceleration. So you should have a very proper grip on this topic, because this will come in handy in the other chapters, even in your maths and other chapters as well. So I hope you guys understood this. If there are any queries, just kindly comment in the comment box below, and I'll be looking forward to them. Thanks a lot for watching, guys.